So hi everyone, today we are going to start with a new topic, that is the second chapter of class 9. It is forces and laws of motion. So guys, यहाँ पर इस chapter में हम क्या क्या देखेंगे? Let us first see. We will be seeing what is a force, the different types of forces, effects of forces, Newton's laws of motion, and momentum and its conservation. So I may upload the video in two parts. So you will find the other parts in its description box. So guys, let us start, and before we move on, I must recommend you all guys to watch the video on motion, right? Because this is clearly having a linkage between motion and the forces applied. So go through the motion, all the videos, and then return back to these forces to have a better understanding. Okay, so let us begin with the very first thing. What is a force? So all must be knowing. In the previous years, we have been talking about the force. कि force क्या होता है? This is a kind of pull or push, or even I can say a hit applied to an object, right? So force is an action, you can say. That action is of pull, push or hit. And a hit be, it is a kind of push. So you may observe the definition of forces in books or at multiple places, defined as force is a kind of pull or push, है ना? तो ठीक है, मैंने hit भी लिख दिया. So remember, this is how we define force. Now how do we measure force? That means what is the SI unit in which force is measured? We will remember Newton, right, represented by N. So guys, if you all will apply a force to any object, जैसे let us suppose ये एक object है, इस पे हमने force लगाया. So in what direction the force will be acting? It is very clear that in the direction of motion. Let us suppose object को आपको right direction में move कराना है, तो force किधर लगाएंगे? In the right direction. So can you all guys apply force without considering the direction? Answer is clearly no. So we can say force is dependent on direction, and this makes the force as a vector quantity. So guys, if you do not have idea about vector and scalar quantity, go through the videos in the description box about the motion. I have already specified that. Okay, so force is a vector quantity, means that it has magnitude and direction, right? Very simple things about the forces, guys. What is a force? It is a pull or push. What is the SI unit of force? Newton. Force is a vector quantity. And what is vector quantity? The one which has magnitude and direction. Okay. So guys, what we are seeing, that if an object is present and if you want to bring that object into motion, let us suppose, then you need to apply the force. Or even if you want to stop a moving body, you need force, है ना? जैसे let us suppose कि एक बॉल इधर से रोल करके ग्राउंड पे आ रहा है, and you have to stop this ball. So you have to apply a force in the direction opposite to the motion. To stop a moving object, in what direction force needs to be applied? In the opposite direction. So force should be applied in opposite direction of motion, right? Okay, moving ahead. Before going more into the details of forces, let us check about the object's state. Object can be in two different states. Either it can be at rest or it can be in motion, है ना? Object या तो rest पे रह सकता है या क्या हो सकता है? Object can be moving, है ना? So let us suppose object is rest. Rest means you are observing the object as stationary item, and motion means object is moving. So definitely it will be moving with respect to the surrounding, right? These are the two possible states that an object can have. So now the question is very simple question. How can you analyze the state of an object? By just looking at its speed, right? If its speed is 0, then object is at rest. If its speed is non-zero, object is in motion, है ना? 2 मीटर या 3 मीटर स्पीड है मीटर पर सेकेंड, तो वो मोशन में है। द नेक्स्ट थिंग गाइस, an important conclusion we can draw is that if I apply a force to an object, that object moves in the direction of force, right? If I apply the force in the right direction, object will move in the right direction. अगर मैं फोर्स लेफ्ट डायरेक्शन में अप्लाई किया तो ऑब्जेक्ट किधर मूव करेगा? लेफ्ट डायरेक्शन में, राइट? सो एन इंपॉर्टेंट पॉइंट that we conclude about the relation between forces and motion is that object moves in the direction of force, right? Object moves in the direction of force. Okay guys, so these were the basic description of what is force and how force can cause the motion. Let us see some of the effects of forces. Effects of forces. Effects as in what all observations I am going to have if I apply a force on an object. तो देखो, ऑब्जेक्ट अगर रेस्ट पे है, इस पे हमने फोर्स लगाया तो ऑब्जेक्ट की स्टेट चेंज हो गई, ये मोशन में आ गया. इफ द ऑब्जेक्ट इज इन मोशन, आई अप्लाई द फोर्स, आई रेजिस्ट इट्स फोर्स, इट्स मोशन, एंड इट कम्स टू रेस्ट, है ना? सो इन शॉर्ट, बाय अप्लाइंग फोर्स आई कैन चेंज द स्टेट, right? I can change the state of an object. Then I can also change the direction. I can change the direction. जैसे क्रिकेट मैच ले लें, उसमें बॉल अगर इस डायरेक्शन में आ रहा है तो बैट्समैन hits the ball and gives a new direction to the ball. So in this case the direction is being changed, and that is as a result of the force applied at this point, right? This is a bat, and at this point I am changing the direction of the ball. Next thing we can conclude about force is that force can change the shape, or you can say the dimension of the object, shape or size of the object, right? Let us suppose this is an eraser which is lying on the ground. You apply a huge amount of force, so you will see that the eraser gets deformed into a new shape, right? So this force is changing the shape. But guys, what we are going to observe closely is the effect of force with respect to motion. इस थर्ड केस में तो मोशन नहीं हो रहा है, बट फर्स्ट और सेकेंड केस दे आर लिंक्ड विथ अ मूविंग ऑब्जेक्ट as a result of the force applied, right? So we are going to take broadly into consideration the effect of force which changes state, or you can also categorize this in terms of change in speed. Okay, there could be change in state, there could be change in speed, there could be change in direction due to the force applied, right? So we have to be clearly focused about the effects of forces with respect to motion and without considering the motion of an object. Okay, so if these effects of forces are clear, let us move towards the section where we will see if the force is applied. Let us see, this is the object at rest. So at rest means its speed is 0. If I have applied the force, object will change its state, तो रेस्ट से मोशन में आ जाएगा. दैट मीन्स इट विल हैव सम स्पीड, जो कि 1 मीटर हो सकता है या फिर 2 मीटर हो सकता है, एनीथिंग, राइट? दैट इज वन पॉसिबिलिटी. अनदर पॉसिबिलिटी इज दैट आई अप्लाई अ फोर्स to a moving object. Let us say this object is having the motion to the right. I apply a force in the opposite direction and I stop a moving object. So if I stop, that means initially the object was in motion state and finally the object comes into the rest state. That means its speed now decreased, right? Let us say it was moving with 2 meter per second or 1 meter per second or 10 meter per second, but finally its speed was brought down to 0 meter per second. So in both these cases what we are observing, object's state is changing, that's right. But if I have to sum up the result of the force applied in both these two cases, I can say force is resulting into the change in velocity, right? Force is resulting into change in velocity, right? So change in velocity, I'll use the symbol delta V. Guys, delta V we already know. Delta means we are talking about the change. If I say delta x, that means change in x. If I say delta V, that means change in V. Okay, this we are already aware of. Okay, so now force is resulting into the change in velocity. So just observe guys. Let us suppose object rest पे है. I apply force and its speed increased from 0 to 5 meter per second, let's say, right? If I apply more force, then its velocity will be increased more, right? So we can say the force applied is directly proportional to the change in velocity, right? More force applied means there will be more change in velocity. And guys, this change in velocity is with respect to time, right? Time is always propagating. It is continuously increasing. So force is directly proportional to change in velocity with respect to time. Now to remove this proportionality symbol, we bring a constant of proportionality, that is m. M क्या है? Mass of the object, right? M is the mass of the object. And delta V by delta t, what it is? It is acceleration, right? Change in velocity with respect to time, that is acceleration. So we get a new expression that F is equal to ma, right? Force is equal to mass times acceleration, right? Okay, so this was some of the basic differentiation, the description about the forces. Let us now see the different types of forces. तो ये इफेक्ट्स याद रखना है आप लोगों को. You all have to remember the main effect of force, that is the change in speed observed as a change in state, right? Okay, moving ahead to the different types of forces. So I will classify forces into two broad types. One, balanced force, and another, unbalanced force, right? Balanced force and unbalanced force. Balanced force क्या है? Let us take a simple example. Let us say this is an object. इस पे मैंने force लगाया in the right direction 10 Newton and in the left direction 10 Newton. तो क्या if this object is at rest, तो क्या ये object move होगा? अगर ये रेस्ट पे है and I apply 10 newtons on both the sides, both the opposite sides you can see, ये right direction में ले जा रहा है, ये left direction में ले जाना चाह रहा है. So the net force here will be 0, right? And in this case we can say that these two forces are balanced. So what is a balanced force? Forces which add up to 0. Forces which add to 0. So we can say when the net force, net means the total force, if it is 0, forces are called balanced force. On the other hand, अगर ये 0 नहीं होगा, it will be unbalanced force, right? Like you can say this object, I pull to the right by 20 Newton and I pull to the left by 10 Newton. This is same as just applying 10 Newton, है ना? Because this 10 Newton is nullifying the effect of 10 Newton from this 20 Newton, है ना? So it's just like if you apply 20 Newton to the right and 10 Newton to the left, it is same as only 10 Newton is applied on the object in the right direction. So here we can say this 10 Newton and 20 Newtons, they are unbalanced force, right? So one more way we can look upon, we have seen that force is a vector, right? Vector has direction. Vector has direction, we are already aware about this. So if I take a force acting on the right side as positive, let us suppose इसको मैं F1 कर दिया, तो F1 what we can say, it is plus 10, right? तो F2, ये अगर F2 है 10 Newton to the left, So I should write F2 as minus 10 because I should take its direction cautiously. So here if I want the net force, if I want to find the net force, I will add these two forces. तो ऐड करने पे कितना मिलेगा देखो, +10 - 10 न्यूटन, क्या हो गया 0 न्यूटन, and this is why we are getting the net force as 0 Newton in this case, right? So in short, we can sum up the forces. Forces are of two types depending on whether it is balanced or unbalanced. Balanced है तो क्या होने चाहिए कंडीशन, net force must be 0. Unbalanced है तो net force क्या होना चाहिए, it should be not equal to 0. So ये तो define किया हमने forces based on whether it is balanced or not. Now we have yet another types of forces based on the contact between the surfaces. So forces are of two types, contact force or non-contact force. Contact force, as the name suggests, these are the forces emerging when there is contact between the surfaces. When there is contact between the surfaces, then the force created as of this result, that is contact force. Example आ गए friction. Friction, what is friction? It is an opposing force which opposes relative motion. और ये friction क्यों act करता है? Because of the contact between the surfaces. Non-contact force, it is exactly opposite to what we defined in contact force. This is the force when there is no contact between the surface. जब कांटेक्ट नहीं भी रहेंगे उस समय भी जो फोर्स रहेगा दैट विल बी नॉन कांटेक्ट फोर्स. फॉर एग्जांपल वेट, राइट, you can give multiple examples, magnetic force, electrostatic force, etc. ये सारे जो फोर्स हैं that is acting at all times even when there is no contact between the surfaces, right? So these are the broad categories in which the forces are defined. So mainly we need to go through balanced and unbalanced force, but to understand better the concepts, better all about the forces, I have also defined contact and non-contact forces. Okay, so before we go ahead to describe all different other types of forces, let us summarize what we have learnt, and then in the next lecture I'll be describing you the different types of forces and some details about the momentum. So yes, let us summarize. So stay tuned guys as well, because in the next class only, in the next lecture, we will be talking about the numericals, right? Because now we haven't covered enough things to go through with the numericals. Okay, so first we talked about force. It is just a kind of push or pull. Then we saw that force is a vector quantity which has direction. Then we saw the different types of forces. क्या क्या टाइप्स देखे हमने, एक तो देखा बैलेंस्ड फोर्स और दूसरा देखा अनबैलेंस्ड फोर्स. Balanced force, what was that? When the net force was 0, the forces were balanced. When the net force was not 0, it was unbalanced force. Well, we also saw the forces based on the contact between the surfaces, and that was called as contact force. And the forces emerging even when there is no contact between the surfaces, they were called as non-contact forces. Examples of contact force: friction. Example of non-contact force, that is the weight. The best example guys, weight always acts at all places even when there is no contact between the surfaces. Well, talking about the effect of force, the main conclusion that we drew was that the force produces acceleration in the object, which you can say in terms of चेंज इन वेलोसिटी विथ रेस्पेक्ट टू टाइम, है ना। तो ये इक्वेशन हमें याद रखना है। All right, guys, see you in the next lecture with some numericals and the types of forces. All right.